I'd like to welcome everybody here. We are expecting a few more people. And just to formally acknowledge that we're all sitting on lands that were mostly, have mostly been taken from First Nations. And we acknowledge that we are sharing the land with them and in tribute to them. And I'm personally on the lands of the Coast Salish people. And Stephen is not. He's somewhere else. The second thing I want to say is that this is a meeting, forum put on by the Energy Subcommittee of the Education Committee of the Suzuki Elders. And the Suzuki Elders are a group of elders who identify themselves as elders and who care about the environment, who want to learn more about what we can do to help prevent climate change or adapt to it as best as possible using ethical values. And today we have speaker Stephen Thomas from the David Suzuki Foundation, who's going to handle the broad topic of clean electricity in Canada and BC. Is it actually possible? Can we actually do this? So welcome to you all. And I'll now ask Gordon, if you could tell us a little bit more about the speaker, and then we'll get on with the session. Over to Gordon.
Sure. As Roz mentioned, Stephen's the Clean Energy Manager at the David Suzuki Foundation.
Sorry, Gordon, can you speak a bit louder? It's
okay. Can you hear me now?
Yep, that's good.
Volume up.
That's good.
That's
Okay.
better.
Crank the volume up a little bit. Okay. As Roz mentions, Stephen's the Energy Manager of the David Suzuki Foundation. And as she said, he'll be speaking on what's needed for BC and Canada if we're going to meet the growing demands for our forecast for our energy grid in the near future. Stephen has a mechanical engineering degree from Dalhousie University, where he specialized in energy systems analysis. Over to you, Stephen.
Okay, thank you.
All right, thanks both, and it's great to be with you. As Gordon and Roz both pointed out, I'm staff these days at the David Suzuki Foundation, and I've been there for about 4 years. I've done this sort of advocacy work around the topics of energy and climate for about 10 years. And before that, worked as an engineer and project manager with different electricity generators and a few provincial governments too. I'll start off by just saying thank you for all the work that you've done as part of your work with the Suzuki Elders, but I assume that many of you have been fighting this fight for decades. And for me, you know, doing this work for about 10 or 12 years now, there are days where I feel tired and I feel like it's all over and I need to quit, and you know, it's hard to keep going sometimes and find that motivation. But folks have been doing this for literal many decades is really inspiring. So I'm excited to sort of give my piece here in the presentation, but get to that question and answer and discussion period where I assume the maybe the more interesting parts of the session will happen today. So I'll just share my screen and speak slowly while I stall to make sure it works. Can folks maybe give me a thumbs up if they can see the presentation well? Perfect, thank you. Here we go. Just 1 second here. All right. So one thing that I forgot to mention off the top here too is that as Rosalind mentioned, I'm not calling in from the West Coast where many of you are. I'm on the unceded territory of the Kanien'kehá:ka in Montreal, in a place where we just experienced a heat dome, not unlike the one that the West Coast got in 2021. But we have much nicer weather here, and I'm grateful to be here on this unceded territory and continue my work with the David Suzuki Foundation from a little bit further east. But today's topic is on the clean electricity, both in Canada and BC, probably a little wider than that too. And as a way of an agenda that we've sort of broken up this session into two parts. The first part will be a real zoom out for what's happening in energy, in electricity, with global and national trends in Canada and elsewhere. We hope that to be one of the shorter parts, but just establish some of what we're chatting about today and have a short question and answer after that. I'll do my hardest to make sure that this presentation is accessible to everybody on the line. As I've already mentioned, some folks have been working in energy and electricity for decades, and certainly can teach me a thing or two on the electricity system. But I want to make sure that everyone on the line we can all have a common understanding what we're talking about. So if I'm using too much jargon or acronyms or that sort of thing, please do call me out on that in the Q&A. Happy to circle back. And then we're going to dig into to the British Columbia context. So probably the bigger part of the conversation will be focusing on BC's energy and electricity context today and the sort of forecast and outlook for what's to come. So without further ado, I always start these presentations. I get to do the fun part as the David Suzuki Foundation's Clean Energy Manager of giving presentations like this, having conversations. It's my face often in media or talking to politicians, but this work is supported by an amazing team of staff at the David Suzuki Foundation from our offices in Montreal, in Toronto, and in Vancouver, doing all sorts of great work. So no one does this work alone, and that's certainly true of me and this team too. So the few questions that I'm hoping to touch on in the first section of this conversation are questions that we get a lot in these conversations on energy and electricity, and questions that have already come up in preparing for this session today. Things like, are Canada and BC ready for new power demand from things like electric vehicles, heat pumps, and so on? Are electricity grids with more renewables affordable? Are they really reliable? How do we know? And is it really that big of a deal? We hear all the time that Canada already has an electricity system that's mostly non-emitting. So what's all the fuss about when it comes to decarbonizing and cleaning up our electricity grid? And can Canada and BC achieve 100% of that clean electricity generation mix by the year 2035? So we'll talk about each of these. The answer to all of them is always, it depends, but I'll try and dig in a little bit more about the context of each. And while I'm doing that, I'll be drawing from a pretty big resource of reports and research that the David Suzuki Foundation has been a part of. I've been a part of about half of these reports myself in this role, but as I'm sure you all know, the David Suzuki Foundation has years and years and years of history with this sort of enabling research for how Canada can use more renewable electricity, can clean up our energy system more broadly. So I'll be drawing from a lot of that. It'll fly by pretty quickly sometimes in the presentation, and when it comes to the charts and resources that I'm going to reference. But just know that all of these are available on the David Suzuki Foundation website. And if anyone wants to dig into any one a little more closely, I'm very happy to send those links around along with the recording and the presentation itself afterward. So that first question, what's the big deal? Isn't Canada's electricity system mostly already non-emitting? And that is mostly true. Compared to some other countries like the United States, and in fact, many countries around the world, our overall electricity system on average across Canada is fairly clean, at least when it comes to not emitting carbon dioxide. That's been true for many years in Canada because of the large hydro resources, particularly in BC, Manitoba, Ontario, and Quebec, as well as Newfoundland and Labrador. But there's large nuclear capacity also in Ontario and a little bit in New Brunswick. But already we begin to see part of what the problem is in Canada. It's not that on average everywhere we have clean electricity. It's really regionally disparate. Places like Alberta, Saskatchewan, where I'm from in Nova Scotia, New Brunswick in particular too, and all of the sort of remote and the remote off-grid communities, the territories all tend to also depend on fossil fuels. So the first problem we have is cleaning up what's already dirty when it comes to fossil fuels on the electricity grid. But the second problem that we're all trying to solve right now is what's called electrification, this increasing electricity demand that comes from electrification. And that's the sort of first buzzword that you'll hear in this presentation, electrification. And broadly, what that means is shifting from burning fossil fuels to get our electricity, burning fossil fuels to get our energy needs, and moving that to using clean electricity to get those same energy needs met. So it's things like driving our cars. For a very long time, they've all been powered by things like gasoline and diesel. It's about switching that need for energy, the need to move a car around and move goods and people around, switching that instead to electric public transport or electric vehicles like cars and trucks. In our homes, there's more examples there with moving from burning things like natural gas or home heating oil to heat and cool our homes throughout the year, and switching that to things like an electric heat pump or other electric heating and cooling methods that can be powered by that clean electricity. It's that big switch. It's that switch from using a lot of fossil fuel energy in our cars, in our homes, and in our businesses to the electricity system. That's probably the larger problem that we have over the next few decades. And that also is where we have most of the opportunity to clean up our overall energy system in Canada. Excuse me. So as a very quick snapshot here, this is a graph going from left to right. The very hard to see like teal color at the top are the emission reductions that are possible by cleaning up the electricity grid. All of the rest of it that you see in blue and yellow and gray are the emission reductions that are possible by switching those means of energy needs from fossil fuels onto the electricity system. It's the vast majority of the opportunity isn't just cleaning up the grid, but putting all these other energy needs onto that clean grid. In particular, transportation, buildings, and industry are the three major categories where we're trying to do that work. So that's true in Canada, that's true in BC, and that's true in pretty much every advanced economy these days, is trying to wrestle with how and when and how much we do this clean electrification work. Really recently, there was a report by a federal arm's length body called the Canada Electricity Advisory Council. I'll use a few of their graphs in my presentation today too, and this is one of them. And it's just another way to see that last graph that was on the screen, where this small gray dot in the middle is the emissions benefit from cleaning up our existing electricity sector, which is significant. But it's this larger blue dot that surrounds it. That's the opportunity that we have to clean up things like transportation, buildings, and industry. So that's the work, and that's sort of what we mean when we say electrification and clean electrification. And that's in fact, that's all of what I'll be talking about today, is things that still live in that electricity world, what's already on the electricity system and the things that are coming onto it. There's a lot of other things when it comes to climate change that aren't really in the scope of this talk today, but we can get a lot done in this electricity conversation. And this is another graph by that same council, and this, I think, does a really good job of showing what the three major phases of Canada's electricity history have been. From the 50s through to about the year 2000, Canada has already gone through a period where the electricity supply and electricity demand have grown exponentially. Over that period of 1950 to 2000, the supply of electricity grew by about 10 times, really exponential growth in the 60s, 70s, and 80s in particular. That's while we were building large hydro dams, building some of the first nuclear sites, and broadly electrifying all of the provinces in Canada. So we've gone through this period of really high growth of electricity once already. But more recently, in the last 20 or so years, between 2000 and 2020, have been a period of pretty flat electricity demand we haven't had a whole lot of new industry or new needs for electrical energy. And during that period, the hard work that we've been doing on the electricity sector is cleaning it up. That's when the first coal phase out happened in Ontario. That's when coal in general has been being turned down across many provinces, as we're continuing with this about the same electricity needs, but switching all of those fossil fuels to clean electricity as much as possible. And then the problem that we have ahead of us between now and about the year 2050 is doing both, is doing that huge growth in the electricity sector overall, while also making sure all of it's clean and we clean up that remaining fossil fuels on the grid. So this is just one more way to sort of look at that problem. And the big green sort of range represents the uncertainty in this too. Depending on what sort of study you look at or whose plan you're looking at, there's a range of about a doubling of the electricity system by the year 2050, all the way up to a tripling of the electricity system by the year 2050. So no matter what way you slice it, it's a huge amount of growth and a huge amount of work to have this happen. But we, of course, at the David Suzuki Foundation, really believe that this is worth it. And that this is foundational to the kind of climate mitigation work we do in the energy world overall. So that's one way to look at this here. And then digging a little bit more into our reports, these other two questions that we're wrestling with off the top: are electricity grids with more renewables affordable? Are they reliable? Is it even possible to build this? And the other question here, can Canada and BC achieve that specific target? What we're going for 100% clean electricity by the year 2035. And I do have a biased view on this. This has been the sort of crux of our work for many years at the David Suzuki Foundation. And the main finding from that first report that I put on the screen earlier, something called Shifting Power. I think many of you were on a presentation that I would have given on this report about 2 years ago. And that came on the heels of about 4 years of partnerships with our academic partners at the University of Victoria and University of Regina, some first of its kind energy system modeling to kind of reckon with that question. And the good news is that there are pathways that Canada can achieve to actually get to 100% zero emissions electricity everywhere in Canada by the year 2035. And that not only is it technically possible, but that there are pathways there that make sure that the energy that people use is affordable and it's reliable. As we're using more electricity, of course, it's more important to make sure that the lights are on when we go to flip that switch. So to dig out some of the sort of main findings of that report, it'll be really quick for me to gloss over these, and I, of course, will send those reports along to folks afterward too. But the Coles notes here are that we put forward pathways for this kind of modeling that prioritize things like wind energy and solar energy, particularly because they're now the cheapest form of electricity in history, and already have a history of being deployed on grids across Canada. But the other things that we looked at to meet these energy and electricity needs are things like energy storage from batteries or hydro or other things. Energy efficiency, certainly very important, to make sure that we're only using the amount of energy that we need to have those energy needs met. And then a series of upgrades to the electricity grid to make sure that all works, and to upgrade an aging electricity grid itself. And then another thing that we focus a lot on are transmission links, connecting the grid between provinces. That's probably something we'll talk a lot about too when we get to that example in British Columbia with its neighbor Alberta. But it's those sorts of partnerships that we're seeing are really beneficial between all provincial borders across Canada. We excluded things like oil and gas on the electricity system, made sure that they were all phased out by that year of 2035. We didn't build any new nuclear energy capacity by the year 2035, and happy to speak to that too. And similarly, new large hydroelectricity dams also weren't built. When it comes to nuclear and hydro, that large scale, many hundreds of megawatts or gigawatt scale, that was mostly selected by the model on the basis of affordability. wind and solar are so much more deployable and so much more affordable these days that it didn't make sense, at least for the model, to take the extra time and the extra money to deploy those other sources. Something else that people talk about a lot these days is carbon capture and storage, using a fossil fuel electricity plant and sticking on this unit to capture the carbon. That too is expensive. And in fact, in Canada and in all advanced economies, it really hasn't been deployed for electricity generation. There's an experimental plant in Saskatchewan, which some of you may have heard about, but the cost of that is hugely prohibitive, when many times more what it would cost to just meet that same electricity need with wind and solar. So that's a snapshot of the things that we had these scenarios that excluded them. And we'll have some more graphs later on about the reliability question here too. The wind doesn't always blow, the sun doesn't always shine. How does it work to have an electricity grid that is actually there when you need it, there when we need to heat our homes in the winter, cool our homes in the summer, and for all of our everyday electricity needs. And that too we can dig into, but that was sort of the strength, or what was the special sauce in some ways of the modeling that our academic partners used, where they had this electricity model that had all these grid nodes, more than 2,000 across Canada, which had a model of the weather and electricity needs and electricity demand on an hourly basis, so that we could have a pretty reasonable estimation of what the electricity needs are on those 2,500 grid nodes in every hour of the year, and try and balance that and build a grid that can meet those electricity demands. So happy to dig into that more, but the short answer of that is that with that modeling, it is reliable. It meets all the reliability thresholds that electric utilities typically are required to use under their regulators. And that's something that that our report was yeah, we were proud to kind of put that in, and that's one of the things that we've been talking with government for years about now, is that reliability piece. When it comes to affordability too, we've already mentioned wind and solar, cheapest form of electricity in history, and that average annualized levelized cost of electricity on these clean electricity pathways are as cheap or cheaper on a whole system basis than our existing electricity system, or the business as usual case that we would project out into the future. So that's good news. It really depends how you do that, but that's good news for us. And then when it comes to jobs and workers, we can dig in a little bit more, but it's about 75,000 renewable energy workers per year are needed for this huge build out of electricity in the medium and long term. And of course, I maybe don't need to remind this group, but we do this not only because it's economically prudent, but that this is about having safer, healthier, more secure communities. It's about getting off of the volatility of foreign and domestic fossil fuel pricing. And it's about bringing benefits to communities with things like community-owned renewables and Indigenous-owned renewables too. These opportunities are just so much greater with this kind of electricity and energy system, and it's a big part of what we believe in too. And of course, with the emission reductions we've already talked about there. So I think in the interest of time, in the interest of getting to those sort of Q&As and testing me for how much jargon I used or didn't use in that first part, we'll have our shorter question and answer period now before we dig into the bigger example of British Columbia afterwards. So Rosalind, please feel free to step in here, and whatever works for you for the Q&A.
All right. So in terms of asking a question, you can put it in the chat if you want, or we're a small enough group where you can just put your hand up and ask a question. So I don't, oh, Simon, you've got a question, go ahead.
Yeah. One of the things on your slide was about storage. Can you just expand on how you're going to deal with the intermittency of the wind and solar? Because it's going to need an awful lot of batteries, or it needs BC, or needs the dams to be converted into some water storage system as well. So could you just expand on that, please?
Yeah, absolutely. And I might say pieces of this for the British Columbia example too, but the main way that we solve that that variability or intermittency problem with wind and solar, wind isn't always blowing, sun isn't always shining. What do we do at night when when of course there's no solar? Is that sharing of electricity resources between provinces. So we had a few different scenarios that we explored with lots and lots of energy storage from things like very large lithium-ion batteries on the grid in all sorts of places across Canada. And we still do see much more of that than we have today, many gigawatts of storage from things like batteries. But we also retrofit some existing hydro facilities that are some are more able to do that cheaply and some aren't, but the ones that were, we retrofitted those with pumped hydro storage too. But the vast majority of how we solve that problem of variability between provinces, between places, is geographic diversity. So having an electricity grid that's much more connected between provinces is the main way that we sought to solve that problem, and how our model balanced that across all of those hours per the day through the year. That's a big difference in how the electricity systems are run in Canada today. There's some sharing between a few provinces, but for the most part, each province is almost its own island, its own jurisdiction of electricity balancing and regulation. And that's the hard part, honestly, in what we see as this electricity future. But also one of the keystones is like more transmission between provinces, more shared jurisdiction, more shared collaboration, so that if we're having a windy afternoon in Alberta, that can meet electricity demands very cheaply in British Columbia, for example, and they can hold that water behind the dam. And then at night, or when the wind isn't blowing, that hydro system is able to fill in the gaps for both British Columbia and Alberta and trade that back and forth. So I think we will get into that a little bit further, but this is a very long way of saying transmission is the main way that we're trying to solve that problem.
Okay, good answer. And we'll keep working with Alberta, Daniel Smith. Now I see Peter has a question, then Roger, then Gordon. So go ahead, please, Peter.
As a systems engineer, I'm asking a more technical question. Could you talk about the issues regarding rejigging the grid from centralized generation, distributed consumption, hub and spoke, to a distributed generation and distributed consumption grid? What challenges does that pose, and how do we rejig the grid? What are the stages and so on? Could you talk around that issue, please?
Yeah, fantastic question.
You can try.
And yeah, I was going to say fantastic question and perhaps an unsatisfying answer. This is what we broadly put in the category of grid upgrades. And those two words are doing a lot of work for the finer details of things like smart metering, about controllable load, having the electricity utility be able to turn off your water heater when the right time is, and having different electricity rate structures that aren't just all on all the time. But if you're charging your electric vehicle overnight, for instance, having the utility have some control over whether that's full on or at 20% or what have you, is a whole suite of things that I think are really necessary. So how we use the electricity system in those grid upgrades is really important, and people in their homes being much more involved. Right now, we're typically across Canada all just electricity consumers. But things like battery storage in our homes, solar panels on our roofs, electric vehicles with very large batteries plugged in our garages are all going to be much, much more common. They're going to help to balance this if we have a smart electricity system. But infrastructure wise, there's also a really big problem of, as you said, the hub and spoke system. We have a large hydro dam or a large coal plant somewhere, and we have large electricity lines to put most of that power into city centers. There's going to be a lot more two-way power system needs, and more power system in general. So not only those electricity lines between provinces, but as we build more distributed wind and solar electricity in particular, we're going to have a lot more spread out electricity system. We're going to need more transmission and distribution lines in places where there aren't any these days, because it's either offshore or in a place where many people don't live. where some of these solar and wind projects are going to be. So again, probably not a satisfying or complete answer there, but it's a lot. It's a huge problem and a huge piece of work in the near future.
Okay, thank you. The next person was Roger, then Gordon, then Alan, then we'll get back to your presentation. Roger, go ahead, please.
Thank you. Hello, Stephen and all. Thank you for the session today. I've got two questions. One is massive conservation. So we cut the waste by a huge amount, 30%, maybe even more across the economy. And the second question is on your reservoir emissions for your quote, clean electricity. What values are you using and what sources of reference can I use on those numbers, please? Thank you.
Okay, no problem. I might hold the juicy part of that first question for the BC example on efficiency.
On the
a ve-
massive conservation, okay, so you'll
conservation
answer that in
piece.
the second part, and the other question?
Yeah, the short answer for you, Roger, is we did everything we could in the model to have energy efficiency, demand side management, LED light bulbs, insulating people's homes, all that sort of stuff as part of this solution. But we can get into a little bit more after. And then the second piece on the emission, if I understand it correctly, like what did we use for how we count the emissions from the decay and methyl mercury and all these sorts of things from behind a hydro dam? They're not zero carbon. There's a number. Is that what you're getting at?
Yeah.
So we didn't use a number. What Canada uses, and the David Suzuki Foundation contests this too, about what Canada uses typically on the electricity and how we count electricity emissions is that hydro is zero. I agree with you that it's not. There's lots of decay and methane and all sorts of things going on. So maybe we cheated a little bit and took an easy route out, because what we chose to do is have no new hydro dams built. So with what's already up there, with what's already running, we think that's still immensely valuable for this problem of cleaning up Canada's electricity system. But we were able to do it without building any new large hydro dams. Yeah, so that's how we approached it.
Thank you.
Okay, thank you. Gordon?
Yeah, regarding nuclear, had we considered, or did you look at the small modular reactors? I understand that Ontario is committed to one or developing one. I'm not sure how far along it is. And certainly it could be applicable in northern Alberta particularly, because their grid isn't very strong up there, but and they need the heat for other purposes. So anyway, had you looked at that approach being somewhat more affordable in the future?
We did. For all of our price forecasting, we used the National Renewable Energy Laboratory, NREL, out of the United States, and their price forecasting. So we use that for all of wind, solar, hydro, everything. And then we did even some more work to try and see what the crystal ball says about these small modular nuclear reactors for Canada's electricity system. And no matter what way we sliced it, these SMRs, small modular nuclear reactors, were just far more expensive than the alternative of using wind, solar, storage, and these grid upgrades that we've been exploring in the pathways. So the only places that we see SMRs being considered or being built are where there's a lot of federal or provincial or otherwise government subsidy and funding, where they can sort of brute force build this thing no matter what it costs. The cost disparity between wind solar storage and SMRs is something between 3 times as expensive to 8 times as expensive, depending on what forecast you're looking at. So just on the basis of cost, and knowing that that'd be something that we'd be attacked on in a study like this is, oh, it's great that you have a clean electricity system, but what does it cost? We were really careful to try and keep those costs low. And that, along with some other uncertainties, is the main reason why we don't see any of the small modular nuclear reactors in these scenarios. But maybe something I should have said too off the top is that the scenarios are something that I can really comfortably kind of reach in and grab a number from as an example, as a conversation piece of like something that we really put time and effort into, that we can say, well, in this case, it works. It's not the only pathway, and the pathway that we put together 2 years ago already in some ways can't be true because, as Gordon brings up, governments are making decisions and doing their own thing already anyway, and putting tens of billions of dollars down for different electricity sources that don't look quite like what our vision would have in our study. But anyway, that's another long answer. Maybe I'll try and keep the answers a little shorter so we can,
Yeah,
can keep it
well,
moving from
people,
here.
of course, are
That's my fault.
asking more than just your first presentation. Now, we've got just 3 more, and then we do want to get back to the next bit, which focuses much more on BC. So, Deb, Jack, you had a question. You put your hand up in the chat, and I didn't see that. So, Deb, I'm going to go to you next, and then it'll be Alan, and then Bob Worcester. Deb, what is your question?
Okay, it's sort of twofold. Does your research encompass the incredible expansion in energy usage engendered by the Bitcoin phenomenon, storage of information in the cloud, and the increasing digitalization of everything that just consumes gargantuan amounts of energy?
That's a good question. Go ahead, Stephen.
The short answer to that one is no. In our electricity system forecast, we had a lot of things that we added onto the grid, which we'll talk about when it comes to electric vehicles and more electricity use in homes. But things like Bitcoin or like large servers for AI and all these things that we hear about are huge electricity users.
Yeah.
And we did not forecast them in our model. And there's some implicit things that you can take from our work that's probably not the best use of that scope and scale of electricity. If we have a problem to meet just our needs when it comes to transportation, heating and cooling, adding a whole other piece onto that when it comes to the Bitcoin and the AI stuff is something that we did not recommend. But who knows? That's another thing that's totally out of our control.
I'm sorry, did you say you didn't recommend them or you didn't consider them?
No, we didn't. Both. We didn't consider them in the model.
Didn't put them in. A lot of them based in the US. So at the moment we're saying, oh, the US deals with it. All right. The next person was Alan. Unmute yourself, Alan.
Sorry. This question you might have more to say about this in the second half, but I'm wondering, is all what you're describing, the models and everything, in the written report that you mentioned? And in particular, I was interested in how you estimated the cost of grid realignment. It seems it's a pretty complicated question, and I just wondered what process you used. You don't need to give the details. If they're in the report, I'll look there. That's fine.
Yeah, they are. They're all there in the report, our cost forecasting and sort of the sources for where we use them.
Mm-hmm.
And if I'm picking up what you're putting down with that question, I think I'd agree that it's really hard to put a number on what transmission connections and grid upgrades are actually going to cost the system. We put in numbers that we think are defensible from that NREL study and other examples in Canada, but these projects are always they always come in late and they always come in over budget. So so I think you're right to question that too. But the sort of numbers and sources are all there in that report, and I'll be sure to have that link as one of the things I send around afterward.
Okay,
sure, we'll get that afterwards. And the last question before we get back to your presentation, Bob?
Yes, my question is jurisdictional. Is there an assumption that we're working only within national boundaries, or is there the possibility of working around Cascadia? There's discussion of sort of continental electrical systems. How do the jurisdictional issues come into play?
What I can say is I see the value in like cross-national electricity collaboration, but that's a question better asked to a lawyer and to someone who knows much better about those sorts of FedProv and international sort of electricity agreements. We can talk about this more on the second half too, but BC is one of the provinces that already has a long history of electricity trade with the United States. But yeah, there have been ideas floated often between New England and the Atlantic provinces and that sort of stuff too. I definitely see the benefit in it, but already just in solving that cross-jurisdictional problem within Canada between provinces is proving to be a huge headache. And I'm sure that's true too when we go across the national border. So I think I agree with you in seeing the value of it, but I have no good advice about how best to make it happen.
All right, that's up to the politicians as well. Okay, we will proceed now with your second part, focusing more on BC, and I know there's some excellent diagrams you've got coming up.
Yeah, I appreciate that. And I think amazing questions so far that I think preempted a lot of what we're gonna talk about here in the second half. That is all about the BC context. So I apologize if this one may be a bit blurry on the screen, but what this is trying to get across here is a snapshot of British Columbia's emissions, greenhouse gas emissions. There's bars there that have snapshots from 1990 to 2020, showing them in 5-year increments. And what it barely shows, if you really squint in light blue, are those electricity system emissions. Very little of British Columbia's electricity has emissions when it comes to the burning of fossil fuels. So most of the problem in BC when it comes to addressing climate change, mitigating greenhouse gas emissions, comes from all those other sectors and comes from either eliminating or electrifying those sectors. So the largest orange piece there is transportation. So there's lots to be talked about when it comes to electric public transport, electric vehicles more broadly. Industry and manufacturing is a declining but still very significant piece there when it comes to that yellow bar. Buildings also significant. That's the heating of our homes with things like natural gas in particular across BC. And then in dark blue at the very bottom there is the oil and gas sector itself. And that's maybe, that is probably a note I'm going to end on there about making wise choices about how we use our limited energy and electricity supplies in BC and across Canada. But this is just to say that BC, like every other province, has a problem when it comes to emissions, but most of that isn't on the electricity system. It's about switching those things to cleaner sources. This is another way of showing that. This is for the 2019 snapshot year. It's a little bit different in 2024, but that large dark blue piece of that chart is all of the hydroelectricity from BC Hydro, delivering cleaner electricity, at least emissions-free at the source. The very light blue there is biomass, a little bit of natural gas there at just 4%, which is where most of the emissions are coming from, and a very small amount of wind and solar. There was a question, I forget from who, in the lead up to this conversation that I wanted to have an answer for too, which is in the finer text here off to the side, which is that BC is one of the provinces that, in fact, among the highest importers and exporters of electricity with the United States. So this history of electricity trade is already a strong one in BC. And it's maybe about 10 or 12% of this overall electricity system that's being traded back and forth with the United States and BC across the southern border. But on average, over the year, in a sort of net picture, it's about 4% of the overall electricity generation in BC is exported into the United States on net over the course of a year. It fluctuates from year to year, sometimes 6-7%, sometimes lower. But I wanted to give a snapshot of that too. That's another thing that's happening in BC's overall electricity picture. This too is probably hard to see if you squint, but this is the hub and spoke system that one of the great questions we had earlier is all about, where the electricity system, the transmission system, the infrastructure that we have in BC is mostly built around having these nodes, these hubs of where the large hydro dams are with big electricity generation, where the city centers are in the Lower Mainland and in Victoria, and industrial uses of electricity too, up in the Peace region with all the industry going up there. That's mostly the story of like how the electricity system is built today. And one of the things that's likely to change if we see this huge build out of things like wind and solar across much more British Columbia's territory that isn't already serviced by BC Hydro's large transmission and distribution systems. This is digging in again to the example from that report that we were talking about at a high level earlier. This is a snapshot about the BC case study in that report in particular. And really quickly, this is an example of how the transportation system changes in how we consider our report. So as a snapshot example here with light duty vehicles on the road in the year 2030, we're already there, in fact, in BC, getting to about 20 or more % of battery electric vehicles. By 2040, they're by far the majority, about 60 or 70% are electric or plug-in hybrid. And by 2050, it's 90% of vehicles on the road are either battery electric or plug-in hybrid electric vehicles. That's what's in the scenario. That's the sort of assumption we're making for how much electricity is going to be used by those vehicles that then gets put into the model for how much electricity we need, when, and where. Similar things happening with medium and heavy duty vehicles, but you're already seeing that there's much less of that we were able to squeeze into the model. Things like hydrogen showed up for us, which we didn't love actually for some of the heavy duty stuff, but there's still much more electricity being used across all transportation sources in BC. Similar story when it comes to buildings, how we heat and cool our buildings for our homes and for commercial businesses. And the story here, for the most part, is that the vast majority of heating and cooling needs in British Columbia move to the use of heat pumps, either ground source or air source heat pumps, with a little bit of remaining electric resistance heating, baseboard heating still present, and still fairly efficient, at least in residential across BC too. So this too isn't meant to be interrogated as the exact right mix, but is something that we wanted to have on the system so that we could kind of pressure test, stress test the modeling to have as much electricity from the building sector as possible to then design the rest of the model and the work. But at a very high level, this is just saying that in BC, in our scenarios, mostly it's electricity being used for heating and cooling in the next few decades. And this is a snapshot of what the overall electricity capacity will look like in BC under our scenario. In the dark blue along the bottom is the existing hydroelectric system, which is actually between 2045 and 2050, some of the small older dams are in fact being decommissioned, and it's economic to build up other things. But for the most part, hydro is steady, no new large dams, but we're using that existing capacity to its fullest extent and partnering it with the huge amount of wind, solar, and storage. So wind is that lighter green, the largest kind of pizza slice that you see in this graph, out to 2050 becoming more than 50% of the electricity capacity in BC. Solar to to a smaller extent, but still pretty significant on the electricity system. And then that sort of hash pattern, diagonal pattern that you see just on top of solar are battery storage that we talked about a little bit already, but that's things like large lithium batteries on the grid that are helping out too. That's the picture of capacity. That's how many things we're building in BC to meet those needs. But this next graph looks quite similar, but you'll see that the colors are a little bit different, because this is the electricity that's actually being used on an annual basis, what's called supply, in BC over these model years too. So we still see hydro as being the most significant, especially early on, in terms of what British Columbians are using for electricity, with wind growing with that really large pizza slice there, solar is showing up too. But then we see a new color when it comes to the electricity that we're using, as this sort of pink color off the very top. And that pink slice, which is pretty significant over the run of a year and really significant in the back and forth in the day, is the net imports from Alberta. So this is one of these collaboration kind of cross-jurisdictional things that we talk about, where if we pretend that there's no political strife between BC and Alberta, we pretend that everyone's just making economic choices, which I know is a challenging thing to pretend sometimes. There's so much economic and grid benefit from having more transmission connections between these two provinces. And the story between BC and Alberta is one where it's in fact cheaper to build wind and solar at scale in Alberta. So the model chooses to build much more of it in Alberta on the Alberta side of that provincial border. So it makes sense for the British Columbian Electric Utility, for the system operators for BC Hydro, to buy that cheap electricity when the wind is blowing and when the sun is shining from Alberta as much as possible. And whenever it's possible for the dams and for the other system, hold that water behind and then use the hydro system in moments where wind and solar isn't as available in BC, or use that hydro in moments where Alberta, in fact, is in a place where the wind and solar aren't as much as they should be, and they need some more electricity. And then that's the flow of electricity backward across that line. But this is just a way of trying to demonstrate that it's pretty significant. And in BC, we end up being a net importer of electricity from Alberta. This is a kind of finer snapshot. Those last two charts that we saw were over the run of decades, and this is over the run of hours. This is trying to model every single hour over the run of a typical week in the winter in BC. And you see the sort of up and down every day. There's that sort of natural pattern that we typically see through the run of a day and through the run of a week, where people use more electricity in the morning when they're making breakfast and getting out to work. And then again, when folks are coming back in the evenings, we see these sort of spikes that are a little bit different everywhere, but this sort of pattern is very normal. And then within that pattern of electricity need, you see all those colors starting to show up. You see that dark blue in hydroelectricity meeting the needs as a sort of baseline, especially in the winter. You see wind coming up and down. You see that pink color with that imported electricity of wind and solar from Alberta. You see a little bit of that energy storage being used at these peak moments too. I know, again, it might be hard to zoom in there and see all the different colors, but that's the sort of story that's being told there in the winter. And the model used this for every single hour, for every single day, all year. But in the report, we had these snapshots of representative weeks. This is another one from the summer in BC, where we see that the wind and solar resources are much more available, that we're using less hydroelectricity, at least in this example week. It's possible that we could be exporting it to BC, but it's not showing up as something that we're using on that hour in BC. And again, we see things like storage and imports showing up for those peak moments. So these are, again, just snapshots about how we think about the reliability and the flexibility of the electricity system as being way more dynamic than the electricity system that we have today, which is the big electricity plants and then the big users in the city, making sure that, you know, we have the what's called the reserve margin, or what's the that we can reliably say that there's enough electricity to meet the demand in any given day, in any given hour. It's a much more dynamic system where electricity is being traded back and forth, and we're responding to, and in fact working with, those changes hour to hour in the wind blowing and the sun shining to sort of make the whole electricity system work. This is something that I sort of alluded to a little bit in the first section. It's another way of showing it on a graph, is the overall affordability. One metric of this is the levelized cost of electricity. When we take all the costs and levelize them over the cost of a unit of electricity, a kilowatt hour, a megawatt hour, what does it cost? So we compared our scenario with lots of efficiency, lots of electrification, and lots of renewables against that business as usual case. And it's marginally more expensive, maybe 4 to 5% more expensive in the first couple years between 2025 and 2030. But then it is in fact more affordable and cheaper in the 2030, 35, 40, 45, and 50 years. that's the story that we're sort of trying to tell is the investment is worth it, not only for climate, for health, for all these other reasons, but it's actually a cheaper electricity system to run if we can commit to making it work. There's a bit here about jobs too. I mentioned the sort of national picture on jobs, and we only modeled the construction and operation jobs of wind, solar, and storage. Of course, there's many more spin-offs from that, but the direct jobs are about 8,500 jobs per year in that wind and solar and transmission build out that we have in our scenario in British Columbia. The last two slides here that I have are sort of trying to answer this question that I actually can't answer on my own. Lots of unknowns, lots of things that I'm certainly not in control of, are questions like, is BC ready? Are BC Hydro and the BC government actually planning for this? How does their vision line up with the kind of vision that I had on the page? And although I am and will be critical of some of the choices that the BC government and BC Hydro are making, BC is actually a place where we actually see this sort of planning at least beginning to happen. For things like actually planning for large amounts of electric vehicles and heat pumps in the near future, for directing BC Hydro and the system operator to make a plan for more electricity in the near and long term, and already starting with some announcements of procuring hundreds of megawatts of new wind and solar and other clean electricity sources. BC is also a place where funding, capacity, and support for Indigenous owned and Indigenous led renewable electricity projects are happening relatively at the scale that we want to see. And although this is slower, there's some talk, at least, about the community ownership, community scale, rooftop solar, community solar gardens, all that sort of stuff that I hope happens too. So I don't want to give them too much credit, but I see them starting to reckon with this in ways that we're not seeing in provinces like Ontario, Saskatchewan, Alberta, Nova Scotia, and so on. So it's a good start, and they need to push to make sure that they get all the way there. And we can, I think, talk about that in the next piece here. But if I remember, it was Deb's question on whether or not we considered things like AI and big data plants for AI and for things like Bitcoin, and the answer was no. And the answer was also no for things like LNG. This is another like big choice that we feel that British Columbia has to make. Where if British Columbia moves forward, for example, with all 6 of the large LNG export facilities that are being planned right now, that is something like 69% of BC's total electricity needs added on top just for those LNG plants. 43 terawatt hours, the same as 8 Site C dams in terms of the electricity need, would just be being served for those LNG export facilities. So that's another example of what we kind of recommend they put the brakes on. We have a big problem ahead of us for making sure that everyday people living in BC have their electricity needs met, their energy needs met, and we just don't see that it's the best use of energy, time, and money to go ahead with these LNG export facilities. There's a million other reasons why we're not big fans of LNG, but this is in the electricity conversation kind of an example of a big choice that a government has to make about whether or not we're actually on track for this sort of thing. And I think with that, that's a good place to leave it for the kind of rest of the conversation. I'm sure there's lots of questions, lots of discussion coming up there too, and I'm happy to sort of flip around to the slides or whatever works best. But thanks for your attention, at least for this first part, and looking forward to the Q&A after.
Okay, thank you, Stephen. Just before I open it up, I had 2 questions. One, your slide with energy efficiency and electrification with buildings. What did you mean by electric resistance?
Sure.
So slide 31, but I don't know what where you've
I
got it?
think I'm happy to just maybe answer that one without the slide. It's the kind of baseboard electric heating that we're
Ah.
used to seeing in homes today already. So I think homes that would heat with electricity in BC, that's what you see along the running board at the bottom of the wall. That what's called baseboard heating. That's what I meant. Electric resistance. That's still 100% efficient, but less efficient than something like a heat pump, which is 200 or up to 300% efficient, depending on the model.
Okay, good. And then the second question I had was to do with the affordability, the low cost of electricity. I didn't quite understand the 0+0 and BAU on that slide.
Yeah, I was using a chart from the report that you kind of need the context from the report. So I think
Oh, okay.
my fault for not making that one more clear. What I was trying to make clear in that one was that we modeled our scenario with all the bells and whistles and all of the clean electricity against a business as usual case. What BC would
Oh.
do with if they didn't care about climate change or they didn't care about building out the grid in that way. And we kind of compared them apples to apples, and that's the kind of comparison we were trying to draw, is that it's still more affordable especially in the medium and long term for that sort of pathway that we were putting forward.
All right, thank you. All right, I have a lineup of questioners. There's Deb, Alan, Roger, and then Gordon. So Deb,
I
can
think
you unmute and ask your question, please?
I think Neil was trying to get on the stack there too. Maybe,
Okay.
just put him on the list. All right, pardon me.
Deb, and then Keith.
I'm not hearing Deb. Maybe you have to come off mute there.
All right, we'll carry on then. Maybe okay. Alan.
So I was struck by the big slice that you have attributed to wind in there, and I'm just wondering. There's more than just the cost of building the devices there. There's a question of finding suitable sites. And I wondered if the report includes an analysis of where the available sites are and how much transmission would be required to make use of them effectively.
Yeah.
In fact, how much land is actually going to be needed to be not necessarily totally devoted to wind, because you can often have multi-use around wind, but is going to be occupied by the plants needed for that purpose.
Yeah, all very valid questions, and it may be a trend that I can only answer these to a certain extent. I can say that the model that we used, the model that our partners at the University of Victoria developed, have these grid nodes, and there's kind of a representation of it on the screen there now. With they have a representation of each province, and they break it up into little pieces. And within that, there'd be a piece of data saying whether or not this quadrant or this sector of BC, the topography was at all amenable to solar or wind, whether or not there's a good solar or wind resource in that area, whether or not there are existing transmission lines nearby, and how much it would cost to build a new line to connect it. That was all part of the math that model was doing, taking into account. Even though it was novel and I think impressive that there was, a few thousand of these grid nodes in our model, it doesn't do the job of actually going out to those places and physically standing there and and making sure that the site is okay. So it's pretty granular, but we're pretty confident that a scenario like this is still very possible, because in every province, and BC too, there wasn't anywhere near the total amount of sites that we deem to be not in a national park or not it has a good wind and solar resources close to lines. There's only a small percentage of the usable space that's actually used to build out that huge amount of wind and solar electricity. So we're confident that that makes it somewhat conservative, that if the exact position that the model shows to stick a wind turbine doesn't work, that there is another one up the road that could. Yeah, that's how the model worked. Hope that helps.
Yep, thanks.
Okay, I'm going to take one question from the chat and then go back to the hands. So Roger's first question, how has the province, BCUC and BCH responded, as BC has a regulatory requirement to be self-sufficient? Okay, that's a very broad question. I'm not sure how you might
Yeah.
answer that.
I think that's what I was trying to say, in that, like, BC Hydro and the British Columbia Utility Commission, we've had lots of conversations with both about our report, about clean electricity in general, about this target for 2035. And that's the kind of credit I was hoping to try and give them, is they're one of the more receptive folks that we have these conversations with. Still a lot of work to do to see eye to eye, and still a lot of work to do to get all the way there to the scope and scale of renewables that are needed. But in the sort of broad planning that we see coming out from BC Hydro and announcements from the ministry, we're kind of encouraged. It's never perfect, but and maybe in a little bit of a glib way, in the fine print of this BC Hydro kind of snapshot for their plan for 2035, they named it Power Pathway, which is very close to the name of our report. So I'll take that as a compliment. But again, sorry, I can't maybe have a more satisfying one there. It's I think it's encouraging that that Mark Jackert is the new chair of the BC Utilities Commission. He had been a partner with us on this report and others. That doesn't mean that everything's going to be all right, but we see the BCUC moving in some of the right directions.
Okay, thank you, Roger. I'm going to go to Deb Jack now. Deb?
Yeah, I don't understand what was going on. With all the talk of the increased numbers of wind towers and the necessity for far more transmission lines, what is the prospective impact on wildlife? That's the first part of my question.
Okay, ask both right now, because we've got a lot of people waiting.
Okay, the other one has to do, and it's somewhat related, but have you considered all of the costs of production and the use of resources to build these? Not the least of which is, for example, the lithium for all of the batteries.
Two fantastic questions.
Big questions. Go ahead, Stephen.
And then they're very fair. So I think what I don't want to do is paint a picture of this sort of electricity future that has zero impacts or is all puppies and rainbows. Everything that industrial capitalism touches has impacts. And although we've already brought up that, you know, the hydro system in BC is touted as clean and zero impact, we know that when we look at it, the impacts to Indigenous communities, to displacement, to wildlife, to migratory patterns, to carbon sinks, in all these sorts of things, have impacts. And with wind turbines and solar panels in particular, most of those impacts come from the building of roads. They're pretty big, beefy roads that are needed for these many ton machines that are moving through. The building of the lines and all that are much, much lower impact than the existing energy system that we have today with all of the fossil fuel extraction that happens. But I don't want to try and pretend that there's zero impact. What we did in the model and what we did in some of our advocacy around this is depend on others like the WWF, the World Wildlife Federation, to give us guidance and to then pass that guidance on to renewable energy developers for having buffers away from protected areas and national parks, and to have migratory patterns sort of shown and redlined for the renewable electricity build out. But in our report and in the model, we couldn't and didn't really do that work to a fine degree. So we have like a few paragraphs in there which may seem very high level because they are, and we kind of put that onus back onto utility commissions, provinces, and so on to make sure that these things are built only where we feel that the impact is lowest. But again, I don't want to try and paint a picture where the impact is zero. So the question is very fair. The last thing I'll say there on bringing up lithium ion batteries, on bringing up the kind of whole supply chain. Can we physically build these things? And if we do, what are the impacts when it comes to mining? These things are made of steel and fiberglass and silicon. That too has an impact. And I think it is one that is a kind of uncomfortable, but I feel necessary balance, where the mining of lithium, the mining of the kind of copper, aluminum, the things that go into this have impacts, and have impacts that aren't what we'd like to see if there was an alternative. But this is another case where the study that we cite in the report and some of our advocacy is that if we compare the kind of mining that has to happen for the existing energy system, because we mine all the coal, we mine all the gas, we mine all the oil, and the impacts of that, just from a tonnage point of view, it's more than 500 times the mining that happens today in the existing energy system for fossil fuels than would be necessary even for the most ambitious build outs of wind, solar, storage, and transmission lines. So again, I think you can tell that I'm trying to have the right balance here, where it's the impact's not zero, but it's many, many times lower than what we have today. And I think that's the best we can hope for until we get we get some better solutions on the books.
Thank you. I think you answered that very well. It is a concern for all of us. I have Gordon next, then Neil, then Keith, then Bob, then Paul, then Roger, then Peter. Gordon.
Sure, just a couple of observations. I noticed on your hour-to-hour chart, like for BC, you showed a hashed capacity for storage. Is that really redundant in BC? Because we already have storage in our hydro reservoirs, and that's some capital. So just a comment on what you're modeling. Would that really, in an area like BC, and I guess Quebec would be similar, with a lot of reservoirs, we would use we would fill up the capacity in our dams. So it just may be an issue. And the other question I have, or comment, and I'm sure perhaps someone like Conrad could correct me in this, but I understand our north-south transmission capacity is much greater than our east-west capacity. And I know there were talks when I think the previous provincial government was talking about Site C, about some transmission line to Alberta, to provide to get them closer to the net zero or greenhouse gas reduction. But that, to my understanding, never got built. Part of the issue is, I would think that the north-south kind of international trading economics they almost trump east-west economics. But I assume that's probably true also in Quebec and Newfoundland. So anyway, those are just hurdles. I don't know if anybody else needs to comment on that, but we have PowerX here. It was a trading arm for BC Hydro that are interested in reducing costs for its ratepayers, and if it's more lucrative to transmit ship our power south, or to buy it during the freshet from the Mid-Columbia hub, then I assume they'll do that rather than shipping it east. Anyway, that's just a brief. I don't know what you can say to that. Just a comment anyway, Stephen.
Yeah, no, great points. I'll do my best to break up that into the two parts on storage and then transmission. The storage one is the one that I have on screen here now, and it is true that BC, especially compared to other provinces in this study that we did, doesn't have a whole lot of battery storage because of that resource of hydro that's ready to go. And what I can say about it is that it was deployed economically. So in around the 2040, 2045 year, we start seeing a lot more batteries being built because the electricity system is growing to such a huge extent that by that time it's more than doubled. And the existing hydro, because we're not building any new dams, isn't able to keep up or have that sort of reserve margin, that guarantee of being able to supply electricity every hour of the year. That storage is really being used as a fail-safe, as something that can be deployed cheaper, or as something that just has to be there and hold energy so that we can account for these things that we don't foresee in the everyday working of the grid. But it's a great point that in other provinces, we do see a lot more storage where it's harder to access that hydro. And then if you can pardon my flipping around here a little bit. Oh, we have stuck on this one. I was trying to pull up a, oh, this always happens. I was flipping too fast and I've crashed my PowerPoint. But there was a chart, and there is it in our report too, which I can link to that question of transmission. And I think your point is correct that we see electricity sharing between Canadian provinces and the United States much more often these days than between provinces because of the economics. It's a better business case to sell electricity to markets in the United States that'll pay more for it. And that's why we feel that the federal government actually has to pay for the biggest chunk of these new transmission lines that we're asking to be built between provinces. So it's not only the politics of BC and Alberta getting along, or you can imagine Quebec and Ontario getting along. But when we take out that element of one province trying to win economically over the other, and we have the federal government step in to pay for at least most of the infrastructure of that line, then that opens up a little bit, I'll say, better faith collaboration that's possible between provinces who aren't trying to milk everything in terms of value out of those lines to squeeze the other economically, but we can actually use it as a balancing resource and actually use it to collaborate to make sure electricity system needs are met between provinces. So I can really understand that this is one of the things that we really are reaching for.
All right, we've still
I
got
hope
quite
it-
a few
hope it happens.
questions, so we're going to move on.
sure.
The next person I had was Neil.
Okay, real quick. I find it fascinating that you're suggesting Alberta give us a lot of energy, but not fossil fuels. It's fascinating. The question I had is, what's the split between solar and wind from Alberta? And then real quickly also, what population assumptions did you make in the whole model? And have you made any assumption that we're going to have less hydropower because of climate change and less rain?
Okay, that's 3 questions there.
And fantastic ones. I get
Take the best
presentations like
2.
this
Okay, go
all
ahead.
the time, and the
Yeah.
quality of questions here are fantastic. So on that last one, short answer is no. It was a gap in our model, and I think a gap in all planning in Canada, that we're not preparing for wildfires, for drought conditions that impact hydro levels. It's a problem, and it's one that we need to better model. So that's a gap for us. And I don't have actually the number in front of me or off the top of my head. In most, well, if I can hazard a guess, I think it was about 80% wind, 20% solar, maybe 70-30 was the build out in Alberta. And that would be the mix of things that would come into to BC. And your first point there is that it's surprising that Alberta is such a renewable energy giant. But that's the case even today. 95% of the wind and solar capacity built in all of Canada last year was in Alberta alone. So despite everything going on in that province, it's still one of the best places to build wind and solar. And that's true of Saskatchewan too, another province with maybe a government that doesn't see that opportunity and has a huge fossil fuel electricity system. The prairies are just a fantastic place to build wind and solar for all those access things that are actually more challenging in places like BC. So it's cheaper to build larger wind and solar. They got good wind and solar resources all throughout the prairies. So that's part of the reason why we see it. So
Okay,
that's my version of
thank
trying
you.
to be quick. Yeah.
Yeah. Keith, you are next. Things flip around, but it goes Keith, then it's Bob Worster, then it's Paul, Roger, and Peter Wilkins. Okay, go ahead. Keith Kennedy.
Thanks very much, Roz. Stephen, great presentation. I saw it 2 years ago or whenever it was presented, and I just would like you to tell us what barriers are you facing to getting this report out to the decision makers that are going to make the decisions to get something done. So what's holding it up and how can we help?
That's a great question too, and I'm very happy to send a couple links along for that one, because most of the work that we've done at the David Suzuki Foundation since this series of reports was released in 2022 is try and work on getting the thing done. Try and work on the federal government in particular accepting these sorts of goals and pathways and making them into regulations. And we've had some success on that. They're called the Clean Electricity Regulations. They started back in 2022 as a regulation that's trying to get Canada to meet this goal, what they were calling net zero electricity by 2035. And what we want to see is actual zero emissions electricity. But huge steps that have never been taken in Canada before to kind of start that conversation to get a regulation like that passed. We have a draft regulation in place now, and they've been kicking the can down the road and dragging their heels to finalize the thing for years now. We hope it'll happen in the fall. They've said it'll happen in the fall. But that's something that we're doing a lot of our work on day to day, is campaigning on that. A lot of meetings with federal officials and provincial officials, because a big part of the reason why those heels are being dragged and why we're not seeing the movement on it is because some provinces, particularly Alberta, Saskatchewan, and to some extent places like New Brunswick, are creating a big stink about this and are saying that it's impossible, or that this frightens or challenges all the development that's happening with oil, gas, and other fossil fuels, and they want to see that continue, and they don't want to have the federal government tell them what to do. And they have a point to some extent, because a real challenge that we have on this is the jurisdiction of the federal government to actually do anything about this problem, because the jurisdiction of electricity is in an individual province's sort of jurisdiction. What the federal government can do is regulate emissions. So they have these regulations on the table that are, in our view, too weak and don't go too far, because they're really nervous about that jurisdiction challenge. So that's maybe a longer conversation for another day. But I think the bottom line there, and what we need help with, is that sort of pressure on MPs, pressure on your elected officials, pressure on your provincial representatives too, to make something like this a reality, to let them know that this is something that you care about, that you'll be having in mind when you're voting, because that's the kind of work we're doing now. So there's a whole other section of work we do on that campaign that I'm happy to send some links along to, and we can use all the help we can get.
Okay, Bob, I had you with a question next.
Yeah, two of my questions were answered, but the third one is geothermal and tidal just a boutique thing at this point, or is it too expensive to compete with solar and wind?
I think that, well, the reason why they don't show up in the model is because they weren't cost effective. That wind and solar were just cheaper, more available, and easier to build in every case. I think that there's still value in exploring things like tidal and geothermal, especially in northern BC, tidal definitely in places like BC and out east in Nova Scotia. We just didn't see that they were cost effective for the model. So I think what our pathway is at least trying to say is that for this first phase of the energy transition, they're not needed. They're not the thing that's going to make or break the pathway. But I wouldn't say no to them if they end up being cheaper or good for communities in the long run.
Okay, thank you. Now, the next one was a question on the chat, and that was from Paul Strom, who asked, has BC Hydro planned, for the reduction in water coming from the glaciers and snow ice due to climate change? I think you actually already answered that you hadn't included the wildfires. So the next one was Roger, and his one was on the hourly June chart. Might it make sense to increase the hydro generation, as this is often peak river and stream flow, and would avoid spillage and lost generation?
I'd agree with that, Roger. And to be honest with you, I don't know why we had to just pick representative weeks kind of at random to put into the graph. It could be that the next week in June had more hydro. And what didn't show up in those graphs is how much is being exported to Alberta or other places. So there could just be an economic thing happening there where it's more economic for the BC system to sell that hydro directly to Alberta. To be honest, I couldn't answer the question, but that statement about there being lots of hydro to use in June I'd agree with you on that.
Okay, Peter, your question, and then we're getting out of time.
So I'd like to talk more generally about the onset of renewable energy. Some of you know, I'm a mentor at Entrepreneurship UBC. I also do work with the Adventures Labs at SFU. So on the one hand, there is not enough lithium to electrify all vehicles. And there are serious environmental consequences. However, I see a lot of projects coming through where there's new battery technology, solid state batteries, also other technologies that are negative or low carbon or negative carbon even. So considering the fossil fuel, the rubber industries and the automotive industries have had over 100 years to develop the internal combustion engine, we're now seeing an explosion of R&D for technologies that are mindful of the objective function that the planet is finite and there are limits to growth. And so while people are talking about the wind doesn't blow, the sun doesn't shine, when we go to a multiple sources of energy, all of these things tend to balance out, plus new battery technologies, not necessarily electrical batteries, but storing by pumping and storing and so on, will work their way through the system. But the public is not generally aware of these things. So that's my comment.
Okay, thank you for that.
So
Peter?
Stephen, maybe you could talk to that.
In the interest of time here too, Peter, I agree with you. I think those are all great points. And for us in the model, it was just lithium-ion batteries. That's just because we could really stand behind the cost numbers of that for the modeling. But I really agree with you that certainly between now and 2050, I imagine that cheaper, less impactful, more available energy storage options are gonna emerge, and that's something that we definitely applaud. Something you said reminded me of one more thing that I want to say about the modeling too, that I maybe didn't make clear off the top when it came to efficiency. And as this whole electrification project is underway of not burning fossil fuels for things and instead using clean electricity, that also is a project of using hugely less energy overall, because the burning of fossil fuels is a very inefficient way to get energy to those end use energy needs. So the internal combustion engine, 20-25% efficient on a good day, and these uses of electricity in electric cars, 100%, 90% efficient in the use of heat pumps, even more than 100% efficient, 200-250% efficient and more. So although it's a huge load onto the electricity system, this is in service of using way less energy overall as a society for the same energy needs. I'm afraid I don't have a graph or a number to help back that up on the page here today, but I just want to make sure that that's kind of clear too, is that this is really inherently a project of efficiency. And I'm happy to do maybe one more, but by 5:30 my time, I'm afraid I do have to sneak away here. So I got to start saying goodbye soon.
Okay, we've got two people. One is Roger, and then Simon will end us off. Roger, quick question, please, comment.
Thank you. Great presentation. I'd like to go dig a little more deeply into the conservation side. If we can cut back way down, we don't have to supply nearly as much.
That's true.
Yeah, I agree. There's a little bit of language there in the report on it, but I just really agree that conservation is first. That using less electricity, using less energy, the cheapest and best piece of energy that we can move forward with is one that we don't have to use at all.
Mhm.
So
Did
really
you
agree with you,
include
Roger.
that in your modeling?
We did, yeah. There's some
Okay.
what's called DSM, demand side management, energy efficiency in the model. Yeah.
Great, thanks.
All right, so Simon, I'm gonna turn to you to wrap this session up.
Okay, so yeah, big vote of thanks for that. That was a really excellent and enlightening presentation. And it really brought home, to me anyway, the increase in electricity demand of ×2 or up even as much as ×3 by 2050, which is going to be a big challenge, particularly for generating capacity that we need in BC. I mean, we're not going to build any more dams, so we need to find it from somewhere. So thank you for pointing all that out. And it's particularly gratifying to us, the Suzuki Elders, that you're keeping the close connection between the Suzuki Elders and the David Suzuki Foundation. So a big thank you for that. It sort of seemed to have almost drifted apart a little bit, maybe whilst the big move was going on, but it's nice to see it. So thank you for supporting that. And so once again, thank you for your wonderful presentation, and wish you and your energy team well in getting the message out about clean energy. So thank you.
Thank you very much. And we've got your emails. We'll get the link for that report for people who haven't got it, and we will send that out to you. Thank you so
Then,
much.
Roz,
you,
thanks for
everybody.
coordinating.
You're
Yeah,
welcome.
thanks very much.
Thank you all.
Have a great evening.
Take care.
Thanks for this, folks.